Thank you all so much for joining us in this new space we're in for this month. Thank you to the Nonprofit Center and TSNE for hosting us. My name is Alexander Gard-Murray. I'm the Executive Director of Passive House, Massachusetts. And we're really excited to be holding this event tonight on designing the future, 3 passive schools in Massachusetts. Before we introduce our speakers and dive into the presentation, just a few quick words about our sponsor for this event. As always, Mass Save with their Passive House and All Electric Homes Training and Workforce Development Program. I'll look for the little slide clicker. There it is. This program, as everybody knows, or should know, oh, it's not clicking. Why aren't you clicking? There we go. This program, as everyone knows, is funded by a coalition of the state's utilities, helping to bring efficiency and the benefits thereof to people across the Commonwealth. And there are really robust incentives for passive house construction. We're going to be talking about schools today, but these slides here are on residential, but there are incentives for other kinds of buildings, both for single family and for multifamily, starting at $3,750 per unit. And we encourage you, if you're going to pursue a passive house project, to reach out to ICF and Mass Save as soon as possible in your journey to execute that well. And if you have any questions, you can reach out to them at passivehousetraining@ma@icf.com, or you can reach out to us to go to phmass.org, and we're happy to help you navigate these incentives and get your passive house projects off on the right foot. And with that said, I'm really excited to introduce our speakers tonight. We've got Kate Bubriski from Arrowstreet. You can give a round of applause for them. We got Ryan Dirks. We've got Nicole Peterson. Ryan Dirks, who is at Perkins Eastman, and we've got Nicole Peterson from Thornton Tomasetti. Jess Farber, unfortunately from CMTA, is not able to join us tonight, but I'm sure our 3 speakers will ably cover the presentation in her stead. And we're really excited to hear from them about a building typology we haven't actually talked about recently at our Passive House events, so we're really excited to hear about all the wealth of experience that you guys have. So another round of applause for our speakers.
So I'm not going to go over this slide, but just we all are aware where we are with the energy code. And this is really applicable to schools specifically because in Massachusetts, we have 2 pathways in the code that we could apply for, right? So we could do the TEDI path, or we could do the Passive House certification. And so these 3 projects were kind of the first projects in the state for schools that were looking at which way do we go. And all of these projects went through the Passive House certification path, and we'll kind of talk about, the challenges there, some of which are very Passive House specific, some are just code in general. They would have been the same under TEDI or Passive House, so it's good to kind of understand where they'd be the same, and talk about why we chose the Passive House certification path. For us, Arrowstreet, and I'm going to talk about one of our projects later, we were very familiar with Passive House because we had done that on the multifamily side, and so we felt that we could understand the verification process and working with the certifier and verifiers. And really when we looked at the 2 systems, we basically said, the only real difference here is only going to add value to our clients. So the main differences of having that more rigorous review or peer review, if you want to call it, in both the design phase as well as through the construction phase with the verifier, and then fully certifying at the end. That was really the main difference of why we kind of went in that direction. And we also weren't quite sure about the sort of very hard prescriptive metrics that we were going to have to hit on the envelope, that we felt we would have more flexibility through Passive House and being able to model that and have just more flexibility there, versus going through the TEDI modeling and having that drive us into something that we couldn't kind of have as much flexibility. And you're all familiar with both FIAS and PHI and understand there are metrics. And this slide's in here to just kind of like highlight that there are differences, especially if you've been going through multifamily, that the metrics are a little bit different in terms of how they're derived. But everything is kind of the same in terms of having this high performing building you know, in terms of moisture control, glazing, condensation, comfort. We'll talk about that a lot, and how it kind of is very specifically unique in schools and commercial projects. And then if you're working in Massachusetts and you're working on a school, you're hopefully going through the LEED certification process as well. If you're going through Mass School Building Authority, you're definitely doing LEED certification, but even other projects outside of that are most likely going through LEED. And so it's really important to understand that this isn't a sort of additional thing you're doing that doesn't align with LEED. It does. There are pieces that you're doing in LEED already that are also going to help you with some of the components through and this is specifically to FIAS. So just understand that that sort of concern really isn't a concern. They are aligned, and it's not going to be doing it one way for this and a different way for that certification, and they really do build on each other. So Nicole's going to talk through some of the technical components of early phase.
Okay, hopefully you can hear me too. Yeah, okay, great. So, yeah, thanks Kate for the great intro. So as the CPHC role, which is what I'm playing in these 3 schools, thinking about the technical details early on and how we engage with the different organizations. As Kate mentioned, these projects specifically went for FIAS. PHA also has their system and early engagement possible. So just coordination with both of those organizations to put projects in the right direction. So whether you're doing a feasibility study or just thinking about it early on, it could really help to think about the key questions that your specific project has. These schools were really each very unique. So for example, for the Squantum School, which you'll see the case study on, we were evaluating where the thermal boundary should be for the roofs. They're pitched roofs. Should the thermal boundary be following the attics, or should it be like a flat roof? And then for Revere High School, for example, thinking about the different systems early on was really critical. So there's really a lot of atypical situations in these non-residential projects. And yeah, so this just kind of covers some of those principles that you all probably know, but just thinking about geometry development. Some of these projects have custom climate data, so making sure you're really refining that. That can impact things like the windows, right? And that can have a big impact, as Ryan will discuss in a little bit. There's custom occupancy and utilization patterns, so really making sure that you're aligned on that. Estimates of office and kitchen equipment, domestic hot water usage calculations. Obviously, a school is way different than multifamily or single family. A lot of envelope optimization, thinking about walls versus roofs versus windows. Where should you, optimize to insulation levels, and how does that all come together? And window comfort criteria is a really big one. And then the ventilation approach, which we'll talk about a little bit as well. So just kind of lay the groundwork for the key considerations. And we are going to jump into case studies.
So we're going to talk through 3 schools today. The Squantum School, which is a project that I'm working on, and then Ryan's going to talk about Charleswood Elementary and Revere High School. You can see that these really are very large public schools. They're in lots of different types of areas, sort of more suburban, more urban. And they are all kind of ranging from Squantum being the smallest at 80,000 square feet to Revere being quite a bit larger. But they do have very unique components to them in terms of the passive house. You'll see when we look at both the enclosure as well as the systems in them, they're very similar in terms of the insulative values that we're doing on the opaque assemblies. And we'll get into this a little bit more, even though the windows are somewhat aligned, they took different approaches to the type of windows and mainly addressing the window comfort. So we'll get into that a little bit in more detail. All 3 of the projects happen to be ground source systems. There's both a central ground source and a decentralized ground source in the case of Charleswood and Revere. That's obviously unique, that is specific to these projects, but not specific to the fact that we were doing passive house. So this could have been various versions of air to water, air to air, different types of heat pump systems. And I just like to point that out. It's just sort of a coincidence. Well, not totally coincidence. A coincidence for passive house, but the incentives that projects can get from Mass Save for the ground source systems, as well as the federal incentives that are still in place till 2032, is really why these schools are doing this, because it costs much less to do a ground source system than any other system, and then they get the benefits of operational savings. The other thing I wanted to point out here, Nicole kind of talked about this a little bit, but understanding sort of your hot water demands and your kitchen demands is really important, but knowing that there's flexibility within this certification system. They all are kind of using a little bit different system for domestic hot water, and that all works within the certification. In terms of
thank you.
In terms of the Squantum School, which is located in Quincy, it's out on the Squantum Peninsula. If you are familiar with
Thank
Quincy,
you so much. Have a good one.
it's connected with a causeway to kind of to the rest of the city. This particular school is set right in the middle of a very dense, sort of low-rise residential neighborhood. It is the center physically and sort of emotionally, if you will, of the community. And so this project is not only serving the school, but it's also a community location and community center and a resilience hub. So while the Squantum itself is not going to really see a lot of flooding from sea level rise because of its elevation, the causeway can flood, and so they will be disconnected from the main part of the city. And so they wanted this to be able to be a resilience hub so that people could come there if there was long periods where they couldn't access outside of the peninsula. As I mentioned before, the project is taking advantage of several different incentives, but when we looked at the operational savings, we looked at this without the incentives factored in. And so we do this on a lot of our projects to help the communities and the skill building committees and other people we're working with understand the added benefits that they're getting from the operational saving side, from having solar on the building, because it's a net zero building, utility savings, AC revenue, things like that, versus the cost or the debt service based on any additional costs. And so once we actually take that and fold in the incentives, which is this is the incentives outlook for that particular project, that gray bar on that previous slide basically goes away. And so that's why these projects are choosing to use the ground source system, because it not only is the lowest cost to operate, but it also is the lowest cost to build. There we go. I was saying wait to respond. It came back. So as Nicole was mentioning earlier, one of the early on things that we were dealing with is that the fact, because this is in the heart of this very dense New England neighborhood, residential neighborhood, there was an aesthetic to having these sloped roofs that we typically might not find in a lot of school projects to kind of blend it into the neighborhood contextually. And so we knew what we wanted to do in terms of the assemblies of those spaces. They are semi-conditioned spaces. There is mechanical units that are located in the eaves or in the slopes, which is really great to be able to not have all that equipment outside. But we really had to understand, for in this case, FIAS, where is that boundary? And there was a really big difference in terms of where that boundary was. And that was sort of more of a modeling exercise, but it is something we kind of went back and forth on multiple times. It didn't necessarily change the way we were constructing insulative layers or air barriers at those different components, because we did need to isolate the semi-conditioned space from the conditioned space anyways. And then that semi-conditioned space, we also had to isolate from the exterior. But it just was something to understand that we needed to kind of test it both ways in the modeling to understand which direction to go. In terms of the envelope assemblies, I think the highlights here for us is that, we've been doing net zero buildings for over a decade for schools, and we were really sort of interested in where we were going to have to go with either the passive house or the TEDI pathway for the new code, and compare that to what we've been doing for net zero schools in the past. And some of the things that we needed to do here that we typically haven't done before is increasing the insulation on the roof. And on this particular project, we ended up splitting that insulation. We prefer to just have it all outboard. But we ended up having to split it because that kind of got too thick to be able to do that exterior to the deck. And then on the walls, we did go to a 6-inch continuous mineral wool as opposed to 4 inches, which would be kind of typical for us. And the slab on grade's a little bit thicker as well. We'll talk about embodied carbon kind of at the end of today's presentation. Because we're adding these extra layers of insulation, we also wanted to understand what the total whole carbon was. I'm going to just start talking about the next slide, and hopefully it will come up. Some other things that we were working with, which are complex with commercial buildings specifically, or steel-framed buildings, are really understanding all of those ways you're going to introduce thermal breaks in your details. Oh, there we go. Whoa, now it went too far. And so those are things that, it's been sort of standard practice, but since we're looking at every sort of finite level of psi value, and again, this is actually universal with the current code in Massachusetts, we're getting into much deeper level than we had before. And so that was challenging, working with our structural engineers to be able to do some of the things that we're doing with brick on what looks like a more residential building, but it's really actually 3 stories, and making sure we can structurally, obviously support the building, but incorporate all of those thermal breaks, at relieving angles, at the parapets, and also things that I hadn't done in the past that we have now done is, how many thermal models can we do of grade beams and interior footing foundations, things that we just really hadn't been looking at before. So that was a fun exercise.
Right, so I'm going to talk about Charleswood Elementary and Revere High School. If I can get the slide to go. All right, there we go. So I'll start by saying that our process for these schools really starts out pretty similar to our typical high-performance schools, which I'm sure you're all aware, but things like continuous insulation, really looking at the window-wall ratio, keeping that in check. Then as we move into more detail, of course, we start to get into the more of the passive house specific calculations and studies. Very early on, we did the FIAS feasibility study, which I think was really critical for us to kind of this was actually viable. And understand that there was not going to be a major cost premium to do passive house. We did do a TEDI versus passive house study, and I think, like Kate found, we were thinking the kind of big difference between the two would really only add value for passive house. We also thought there was a chance TEDI was actually going to require us to increase insulation in the walls for this project. I will say I wouldn't necessarily draw that conclusion in every project going forward. We're going to continue to study this, but that's something we'll plan on looking at. Can you all hear me pretty well? Just want to make sure. Great. And then, of course, it's really critical to hire an experienced CPHC and verifier as well. It just makes the whole process much easier. Then, of course, as we get into more detail, kind of getting into the nuts and bolts of the passive house process, we did want to balance passive house goals with daylight and indoor environmental quality to make sure we weren't kind of sacrificing that. As we'll see, there are some public bidding challenges with how we can kind of enforce these strict requirements and still make sure there's at least 3 bidders that are capable of bidding it. There's some modeling challenges that I think I'll lean on Nicole to fill in the details for that. And of course, lots of thermal bridge analysis, and of course, some time in the specs looking at air sealing and kind of what we want to enforce for testing. Just a quick note on orientation. We see a little bit of an energy use reduction from orienting the classrooms north and south. Can you hear it? Okay, yeah. Okay, so we do see a little bit of an energy use reduction and a little bit of a system size reduction from this, but the main benefit to doing this is we get much better daylight in the classrooms and more even distribution. So again, trying to make sure the indoor environmental quality is equivalent to our typical schools. So I'm going to talk a little bit more in depth about Revere, which I think is a really interesting case study. As you can see, the existing school is here in the middle of the page. So Revere, as you all know, is a community just north of Boston. And the big things we're dealing with here is that our proposed site, which is kind of the green shape that's to the right, that's certainly going to be within the floodplain. It's technically not right now, but it will be in the very short future due to climate change. So that was a big problem we had to overcome. In hindsight, we actually were happy we ended with this site because the only other options were kind of tearing down low-income housing for veterans or putting it next to like a huge oil refinery. So we thought, in comparison, this is great actually. We got the waterfront view. So we'll deal with the floodplain. So of course we lifted the whole building above above the ground plane. The first floor is 19 feet above sea level. The floodplain, the design flood elevation per FEMA is 14 feet, so we've got a little bit of extra room there. And then everything below that level 1 point is hardened against the flood waters. So of course anything that goes through there, it's just the stair towers and the elevator cores. Everything else is designed to get wet and dry out. And we also found these flood vent products that actually intentionally allow the stair towers to flood to kind of equalize the hydrostatic pressure and prevent structural damage, and then also let the flood water out once they recede. And that even has some air sealing ability, so that can be part of the passive house envelope. So of course, when you lift your whole building above the ground, you create a few thermal bridging challenges. And so we kind of looked at this pretty early, like, is this going to blow up our budget by doing a bunch of, structural thermal breaks for a 5-story building? We thought that was going to be cost prohibitive. So we did a study, I think, a therm model and maybe an SD with FIAS to kind of see, is this going to totally blow up our project if we have to do this without an actual structural thermal break? And we found there is there's certainly for a passive house project, this is a pretty bad thermal bridge, but it's still less than what you would have for a comparable, shelf angle, which would be about 0.35, maybe 0.4. So it's kind of mitigating the thermal bridging at a much more cost-effective way when we just extend that insulation out in the top and bottom of the slabs by 4 feet. And the interesting thing is, even though we have almost 600 linear feet of this with this huge project, this only affects the EUI by 0.01. So we still have to do our checks to make sure we're not causing condensation problems. And of course, we have to just track this stuff. We kind of keep track of the thermal bridges. But I think it's just worth mentioning that on these really large projects, we don't have to be quite as concerned about every little thermal bridge as we might on a smaller project. But I would not necessarily recommend doing this if you had a wood frame building or a much smaller building. So as we've mentioned, the window comfort criteria, I think is, for us at least, was one of the biggest challenges, at least on the architectural side. So for FIAS, this is based on the climate that you're in as well as the window height. The window height is defined as kind of the full height from each individual light down. So you're essentially adding them up. So to give an example, the blue window here in the middle, it's an operable window. So even though that light is only 4 feet tall, it actually has a comfort limit of 6 feet tall, which per FIAS that drops the required U factor to 0.18, which starts to approach the limits of what's possible for aluminum operable windows, at least the ones that we were looking at in terms of the bidding requirements. So that was kind of a lesson learned from Charleswood, and we'll get to in a little bit how we fixed that. But we were very close to passing, and it actually speaks back to the custom climate file, because we actually would have passed this if we could have used the Worcester climate file, but we had to use a custom climate file, which was even more conservative than we thought. So lesson learned, you want to have some extra wiggle room or extra flexibility in those numbers if possible, if you want to get the comfort criteria from the windows alone, but you'll see our solution. And then we do need to evaluate the whole window as a single U factor, which is a world that I'm not used to thinking of. Honestly, I think normally I'm used to thinking of the NFRC values, but that's just something else that you have to do that maybe window manufacturers are not used to doing. I'm not the expert to talk about PHI, but I will say that's, they have some similar requirements, but based on the interior surface temperature, and I'm sure, Nicole, you can add anything if I missed anything there. Okay, so recommendations, what we learned from Charleswood. Like I said, we need the window-specific U factors, so that can be difficult to get before the project is bid. We had something like 30 different window configurations in Charleswood, so manufacturers don't necessarily want to give you all those calculations before they've won the project. So we were shooting in the dark a little bit. We were able to get the estimates of them and kind of, we talked to a lot of different people, but that's kind of where we landed. Of course, it's best practice to use products in the FIAS database or the PHI database. But even very small deviations from exactly what's listed there mean you can't use that data and you have to derate it, at least for FIAS. So that was a challenge for us because we wanted to use a different IGU. We have school guard glass. You know, there's other things that are typically not included in the FIAS database. Different manufacturers have different capabilities for casement and awning. Some are better at casement, some are better at awning. So again, you kind of have to structure your specs around allowing what's the, you know, can we get at least 3 manufacturers that can actually do whatever we're specifying? So of course we would recommend using punched windows because you get pretty good performance at a pretty good cost. Curtain wall for larger areas, and then recommend against storefront because of course not as good of performance and it's harder to air seal. But we do have a little bit of storefront at Charleswood for some of the entrances, which I think speaks to the fact that FIAS is flexible enough that, you know, there's no prescriptive limits on things that will, you know, break your project if you use it. And then I think we will consider UPVC or fiberglass in the future. It certainly would be easier to meet the comfort requirements, but there's maybe some material health concerns with that we could probably have a whole nother session to debate, especially for the UPVC. But in any case, we use aluminum because that's what we typically would do for our schools. But what we've landed on is recommending no taller than about 6 feet for the whole window opening, and then putting the operable windows below because of, again, the fact that it's an additive criteria means the operable windows are going to be a lot harder to meet if it's above windows. If that, hopefully that kind of makes sense. So finally, how we did meet that is there is an exception that allows you to use some form of perimeter heat. So that can be a baseboard heat, or it can be supply diffuser that's in the air and the ceiling that's washing the window with air. Just as long as you confirm and prove to FIAS that the throw of that diffuser is actually getting to that window. So, and we were lucky, and this is actually Revere, but in Charleswood we had a very similar study where we found, yes, the windows are well within the throw of those diffusers. There should be no concern for comfort at these places. So even though Charleswood just barely failed the prescriptive U factor requirement, we can still satisfy the requirements by that, the thermal comfort of the kind of ventilation system. Is there anything else you'd add? This is where we transition to Jess typically, but we might need to I might lean on you.
Yeah,
Nicole,
sure.
to kinda,
Yeah, I would just add that, yeah, the windows, it was a big deal, and you know, working back and forth and coordinating as a team was the best path for it. And just like, you know, the different systems are willing to work with you. There are prescriptive requirements there for a reason, but even the height requirement, it was adjusted partway through. It used to be the whole height, and they made it additive so that we could, as long as we proved that it'd be comfortable and no condensation risk. So
yeah, thanks. So I guess I can probably speak to this a little bit. So of course this is our gymnasium here in the middle. We do some very tall areas of curtain wall that we're trying to get some views down to some of the people in that space. And so of course FIA said, hey, that's way outside of the thermal comfort limit. So CMTA worked with us. The red little dots there you can see, that's a destratification fan that's intending to mix the air in the space and make sure that those windows will be comfortable. And I'm actually trying to remember, they basically had to kind of engage with FIAS early on and kind of say, this is something we've done in other schools. After we kind of showed them the quantitative data as much as possible, FIAS accepted this. Do you have anything else you'd add to that?
yeah, exactly. And they wrote a long narrative, so, and then that can be a precedent, hopefully. So
Yeah.
Yep.
So I might give the,
Yeah, I'll switch. Yeah. Yeah, unfortunately, Jess could not be here from CMTA. So we'll do our, oh yes, sorry. Yes, got it. Thank you. So yeah, just to, you know, thinking on the mechanical side and how it all works in, for a lot of projects, you're already doing a ASHRAE whole building energy model for other reasons, perhaps, or you know, for design assistance for other reasons. That's not always the case, but when you are, it's really helpful to integrate the whole building energy modeling and the FIAS or PHI modeling, and using the data back and forth to help each other. So in this case, we were able to, this is Charleswood, there was the ASHRAE whole building energy models were done before we started some of the FIAS modeling. And so we were able to actually use a lot of their information on the lighting and the equipment, and just having that integrated, I think, is the best approach. Then we're not guessing as much, right? It's really tuned to reality. But it's like, you know, and also the schedules as well. So thinking about the airflows, which I'll talk about when we go to ventilation. But yeah, but it's a circular process, as it always is in integrated design, but yeah, definitely helpful. And then, yeah, just thinking about the systems and, you know, integrating the best systems to provide the fresh air and to be efficient. The energy recovery wheel has a big impact in the passive building land, and making sure that sensible recovery effectiveness is optimized, really maximized as much as we can get. And these projects all happen to have demand control ventilation as well. So thinking that through as a team. And I'm not sure what he was going to say for this slide, so I might just skip it. We'll go right into.
I had a guess.
Did you know? Yeah, you go. Yeah.
I think it speaks to the fact that FIAS is not used to working on mechanical systems of this type with this large of projects, and so their modeling tools are a little bit more, you know, simple or, you know, streamlined, I guess. And so there had to be a way to translate, I think, between the really in-depth results from the CMTA models. Is that kind of ringing a bell at all? I think it was in terms of like estimating the actual effectiveness of these systems at different flow rates.
Brian. Great. So yeah, jumping right from that into some of the specifics in terms of that, like how we actually modeled these. So this is going to go into some of the technical weeds. So just going back to the occupancy and utilization that I mentioned at the beginning, just really integrating this. What we're looking for is not the code occupancy. We're looking for, what we're trying to do when we're modeling these projects is making sure that we're aligning to what the typical situation is going to be, not the peak. So thinking through what's the average and what's the average occupancy going to be? How is it going to flow for the different spaces? When are they going to be in use? When are they not going to be in use? And calculating that early. And all of that goes into the FIAS criteria and the internal loads. And then for the ventilation side, this was a really interesting challenge. Understanding and modeling the typical operation here, dependent on whether we had a whole building energy model built at the point that we were starting the FIAS modeling, made a difference. So, and also dependent on the performance buffers that we had. So we have this table here summarizing the 3 projects. So 2 of them had whole building energy models being built or already built. There were different performance buffers. So dependent on that, we decided on how we would model the ventilation. And for the Charleswood and Revere, we were able to use a pretty standard pathway of just basically taking those utilization patterns and then figuring out, okay, at those times, how much is the airflow going to be ramped up? What's the CFM going to be at those specific times? However, that can lead to overestimating the ventilation a little bit and not really modeling the DCV and the control that you're getting by managing the space in that way and optimizing it. So for Squantum School, we had less buffers. We actually had to develop a specific protocol. So I'm just going to walk through that a little bit. So yeah, our first approach of the utilization patterns, you are not meant to read any of these tables, but just show you how it kind of works. For each of the different spaces, we're looking at the CFM, the hours of operation, we're multiplying all of that out, and then we're putting those directly into the WIFI passive or the meter model. And yeah, it's quite variable by space, but not too many spaces, and we're really able to get to a level of detail that we feel reflects reality here. Option 2 for the Squantum School, we developed this DCV protocol. We worked really closely with Al Mitchell at FIAS, basically trying to figure out like a mini environment for each room, dependent on the room size, the occupant activity, the airflow rates. And the goal of this was really to generate the pollutants and the CO2 generated so we could figure out the amount of ventilation that would be needed space by space. So yeah, there was a Python script, and it kind of iterated and generated the values per space. And then we took that combined with manufacturer data to generate new sensible recovery efficiencies. Again, not meant to read the tables, but just kind of all the math behind it. And if the presentation gets distributed, you can look. And yeah, so it was just a process of figuring out what's actually happening, what does the manufacturer, what information do we have from the manufacturer, and then getting those new SREs. And then ultimately, this is the benefit. So the sensible recovery efficiency that we had in the mechanical schedule, you can see in the second to, you are meant to be able to read this table. The second to last column, you can see those are in like the 70s or like low 80s. But when we did this method to really approximate what it would actually be when you're modulating that airflow downwards, and not at the peak all the time, the new sensible recovery efficiencies were much higher, and this helped us so that we did not have, we were able to pass the criteria. And now we actually have a buffer on the project, so maybe we didn't need to do this. It would be good to look back in retrospect, but just to kind of demonstrate there's different ways to think about these calculations, but really what our goal is to figure out what reality is and how we can reflect that. I think that's the end of my part, so I'm going to hand it over to Kate to talk about whole life carbon.
We only have a couple of slides left, so I'm just going to sit here. So as mentioned earlier, we were kind of, as we went through this project, and it was our first school under the new updated stretch code, we had this mindset of, okay, we've done a bunch of net zero schools. What is different about this, other than the process and going through the verification and certification? What is different in terms of the actual built design of the building? And so around the envelope, that is where we were seeing the main difference. And so we wanted to understand, we took sort of the typical new construction net zero buildings that we had been doing that are operating at UIs of around 20 without renewables. Where would we get with this building, with this enhanced envelope? Where are we going to get in terms of energy reduction through modeling? Of course, we're not at the operational phase yet, but also what's the impact of the embodied carbon on the increased insulation on the walls, on the roof, under the slab? And so we are seeing on this particular project and where we ended up for our assemblies compared to what we would have done if we were, say, not under this code and we're just aiming for an all electric net zero building, there is an increase of embodied carbon. It wasn't significant. And so what this is kind of telling me is this might be unique to this particular project, right? We're running LCAs on this project kind of in two different design scenarios. It might have been different on another project. And so I think it's telling us that we need to keep our eye on this, that we want to make sure our goal is sort of reducing carbon overall and not just focusing on operational, but that it's not significantly more embodied carbon. And so on another assessment, and Ryan will kind of talk about an assessment that he did on his projects, I think if we just want to make sure as a state that we're tracking this and how can we start to get some of these case studies of projects as they've gone through design and start to understand sort of more holistically where projects are kind of ending up. And so that's something we're doing on a TEDI project right now as well as some non-school projects. So hopefully we'll have more data on that. Hopefully all of you or other people will have data as well that we can kind of start looking at to understand if there's things that we need to adjust potentially in our codes to make sure we're looking at that total carbon perspective.
Right, just a couple more slides. So, I just skipped one. I'm sorry. All right, we also did a whole life carbon study and found a very similar takeaway that there clearly is an embodied carbon premium in terms of the building envelope, which are the numbers that you see up there in red. But we also talked to CMTA and did a really in-depth embodied carbon study of systems with them based on some research we'd done in previous projects. And in some cases, we were seeing that the embodied carbon savings of the envelope upgrades relative to IECC 2021 prescriptive code minimum might actually offset some of the embodied carbon or maybe even all of the embodied carbon from the envelope upgrades. I will say this is very project specific, but I think that's something, if you can get a good engineer to actually start downsizing systems, reducing the number of geothermal wells primarily, also the number of PV panels we need for net zero, because there's a lot of embodied carbon in PV panels, So at the end of the day, we are seeing that there's at least a partial offset, some of the embodied carbon in the envelope with the embodied carbon savings in systems, but it is a very slippery concept to grasp, and there's not a lot of great information out there yet. So that's where I would say to get a great engineer that's kind of studied this stuff. And then in addition to that, there would be further operational carbon savings over the life of the building. So just a couple quick thoughts on construction. So as you probably know, so any slight changes in the performance for instance, insulation or the spacing of your roof anchors changes, all that stuff has to get captured in the final certification model. So obviously you do want to have some extra wiggle room in your final numbers from the final design review, I should say, because there are always changes that happen in construction. The contractor needs to kind of, we need to be upfront with the contractor as well as the owner about coordinating the testing during construction, whether that's a standalone mock-up or first install. I think there's a case to be made for both. They can work, I guess both can work, depends on project specifics and schedules and so on. But there needs to be some kind of testing to have a better chance of actually passing. On Charleswood, we're planning on having one wing of the building that's kind of walled off and do a pre-test. Which makes sense because we have a firewall that goes through the whole building that's big enough that we actually can do that, but that is challenging on some projects that maybe don't have a firewall. It's certainly something specific to Charleswood. And so I guess finally the untested air leakage rate has to be used for the final model, so again having that extra flexibility here. And the last just little thought I'll share from Charleswood and Revere, again because these are such huge projects that are very different beasts than the typical multifamily project. We did reach out to FIAS and see if they would consider some modifications to their typical air testing protocol, which they set up a call with us and kind of discussed it. And ultimately, we kind of landed on a compromise of slightly modified version of essentially ASTM E779, which is what we typically would use for high-performance non-passive house schools. So again, wouldn't promise that's going to work on all FIAS projects, but I think, again, if you can make a case to them and use quantitative data if at all possible. They are willing to work with you in some cases, but doing that early is very critical so we can be sure that it's not going to cause problems with the design schedule. And, do you guys have any other comments you want to add?
Let's have a round of applause for our speakers. Okay, we're going to take some questions from here in the room, and we're going to try and take some online through the mics, this time unmuted on purpose. But first we'll start with folks in the room. Is there anyone who wants to start us? Mr. Moore.
Did Thornton do the verification?
Interestingly, MSBA projects for commissioning, both envelope and MEP, you get assigned your commissioning agent through a pool that's pre-vetted, and they pay for that service. And so we talked to them very early on and said, FYI, did you know that now projects are going to have air leakage testing, and we're actually going to go after passive house, so we need other verification. We would really love you to assign us somebody for envelope commissioning who can also provide verifier services, and they were thankfully amenable to that. And so we have BEC on Squantum. Airtight is on the other two.
We're hoping to do another presentation once the buildings are actually constructed, and then they'll be on this panel. So, yeah.
Other folks in here, or do we have anyone online yet? I've got a question if not. I'll ask mine. Okay. I think, Kate, you had a slide with the operational you had your slide with the carbon calculations, right? Maybe can we go back to that for a second? Because I was just curious because you had the embodied carbon, the construction, and then the annual operational carbon, but is that just the operational carbon savings for 1 year, or is that operational carbon indefinitely?
No, then we looked at it over the life of the project.
So that's not annual, that's lifetime operational carbon. Okay.
Well, it might be annual that I wrote on there, but the calculation is looking at it over the life of the building.
Okay. I just wanted to make sure that it wasn't annual 1 year compared to embodied. Okay.
Yes.
All right.
What's the number on there?
It's -7%.
No, the Oh, sorry. I thought you said it actually had the annual. I was like, it has kilowatt hours on there? No. So that was based on the life of the building.
Okay, all right. Mr. Auerbach.
Thank you guys for being here. Am I being picked up on the mic? Yeah, okay. Yeah, along those lines, for example, what is a lifespan of these buildings? So that's kind of question one I have. Question two is, 10 years or more of doing these kind of buildings, have you studied the impacts or the, how, let's say, a diffuser fan or a de-stratification fan, how that's actually being used over the lifespan? What sort of, I guess, tracking behavior have you gathered on your structures over their, 10 years of use or 15 years of use, or I don't know what your longest buildings in operation are? So those are kind of my two questions.
So lifespan, I mean, for like this assessment, we're looking at 60 years. We know that these projects will probably be in operation for 75 years, maybe longer, just because being able to replace and upgrade schools is difficult. But that's sort of, in terms of your other question, I don't know that I necessarily have a good response to that. I mean, we obviously are looking at replacement costs and, life cycles of equipment. And then in terms of these projects, and then also projects that we've been, doing for the last decade, those projects are doing a lot more monitoring in terms of understanding what's going on with their systems. I think that was increasingly beneficial when then Mass Save sort of made that part of their Path 1 program, because now the things we've been telling our clients for years, and sometimes they wanted to pay for it, sometimes they didn't. Now they see like, oh, I don't get the rest of my money until I really start to think about my project post-commissioning for all the other actual operational verification. I don't know if that answers your question, but.
Yes, certainly starts to. Yeah.
I could just chime in a little bit too. So, we haven't done this for passive house schools yet because they're obviously not built yet. But for our typical high performance schools, we try to do post occupant evaluation. I wouldn't necessarily say it's getting into specific as fans, but we are going in and measuring CO2 and checking daylight measurements and kind of tracking to make sure that our designs are actually doing what we were hoping they would do. It's generally much closer to when the building opens, but so I'm not sure we can say we have 15 years later that kind of information, but we have at least tried to track the performance after the building opens. And then I know we've worked with CMTA as well to check the energy bills for buildings for at least a couple years after they open, just to make sure things are still working as we intended and weather normalized. So at least in the kind of shorter term, we're trying to look at it for high performance schools, and I'm sure we'll do it for the passive house schools.
Okay, we've got someone online, it sounds like. Do you want to call on them, Beth? Oh, Kurt Lamar. Kurt Lamar, can you hear us? If you can, you can go off mute and maybe we'll hear you.
Sure. Can you hear me?
Yes, that's Kurt Lamar. Look at this technology. All right, Kurt, ask your question.
So I was just curious about the energy efficiency of a school when the occupancy is probably less than 20% a year. How do you control the efficiency during downtime?
I would say these schools are rarely ever seeing downtime. Schools these days are community centers. They're operational 10 hours a day at least on the weekends throughout the summer, both with, summer camps, summer school. A lot of times in the communities we're working in, these buildings have spaces that might now be the only place in the district where we finally got that training room that we need. And so now other schools in the district are also using this, sometimes during the school day, but also after hours on the weekend. So I would say the thing that we plan for, and Nicole talked about this a little bit earlier, is that utilization and occupancy is really important, but it's very important to be very realistic about that, because there are going to be people there all of the time, and you need to plan that, you know, they might change. It's not like they're in every building or every room all the time. They might only be using the gym, cafeteria, certain wings, and we've also on our projects, and we did this a little bit on Squantum as well, like zoned the wings so you can shut ones down because maybe we're not using both floors of classroom, we're using one floor of classroom for this part of the summer or something. But I would say it's usually the opposite, that they're so used that you really need to understand what the profile of occupancy looks like and plan for that.
Yeah, and I think
Okay.
that's just like one of the goals that we've had like for these projects is just like really trying to think that through for each school. Yeah, are the classrooms going to close down? But like Kate said, the community areas, the gym, the offices going to stay open. When are they going to be open? And finding the ways to model that and reflect that, so that we're not overestimating or underestimating, but trying to target it just right. Yeah.
Got it. Okay, great. Thank you.
Mr. Mahoney.
Thanks for this presentation. This is excellent, inspiring work. Through the course of where you are right now, what would you say is the single biggest surprise? It could be anything, good, bad, just like a moment that, you know, you're like, wow, hadn't really thought of this.
This will be a silly one while I'm thinking about my real one. The other day, we realized they put extra insulation in a part of the project. And it was like, wait, that's only supposed to be whatever it was, 2.5 or 2 there. And so then we were like, well, they put more in. Let's update it in the model. So Nicole went in and they updated the model. And I was like, oh, yes, we have a little bit bigger buffer. So that was a nice surprise. But I don't know. I'll have to think. I feel like we were just in the footings. Oh yes, when FIAS asked us
To
to
model every footing in the project for Squantum.
I feel like I was always the bad guy on the calls with them. I was like, Nicole, I'm just going to be the bad guy here. I have the contract with the client. I have to keep us reasonable. And I'm like, you want me to do what? Yeah, we're not doing that. Right. So I think Ryan kind of alluded to this earlier, right? It's about having that flexibility and having somebody to bounce things off of. Like in Massachusetts, we're doing 30% more above ASHRAE 62 for our ventilation. And that's what and we're also using DCV to help control that and control the energy piece. And we needed to be able to work with FIAS to like accurately represent how the building was going to operate and have that extra ventilation for air quality and health, and see the energy efficiency component of the DCV. So I think that's where, again, this sort of, if I have to go TEDI or I have to go this way, that's another benefit, is that you have an entity that you're kind of balancing things off of, and you're not stuck in like a rigid, senseless, non-design model that's telling you got to do X. So I think that was something that I was surprised by, because I was like, yes, this is like great system. Why would it, you know, why are we having such a hard time getting this in the model accurately? And why, like, how do we get it to really accurately show what we're trying to do? So that was surprising.
Yeah, so I think mine is probably just thinking about, I guess, like, it's not necessarily surprising, but I feel really lucky to be the CPHC for these 3 projects. And they're, you know, on the cutting edge. And I think just joining the project teams and seeing everyone's excitement and willingness to coordinate and talk through everything. I feel like sometimes there are projects where people think that you have to do a certain thing for sustainability because the planet, you know, like, and they don't really understand the importance of it. And I think for these, the whole project team, the whole construction, like everyone involved really understands the depth of this and the importance of it. So I think just like the ability to collaborate really easily and lean on the different skill sets and strengths of the team. So not necessarily that surprising, but I think sometimes you don't have that, and that was definitely present. That's been present on all of these projects. Yeah.
To say this because of how much time I spent studying thermal bridging in my life, but my surprise is how little thermal bridging mattered at the building scale that we're working at. but that assumes that we've already done continuous insulation and we've already done like the best practices, but I'm talking about, again, those linear thermal bridges, point thermal bridges. Again, that wouldn't necessarily hold true for smaller projects, and there's other condensation concerns. But I think for me, that's been a takeaway of, we can try to find cost-effective ways to do passive house buildings, and we don't need to obsess about every little detail. We can still do best practices for the most part, prioritize the ones that we know are having a bigger impact. And I think, honestly, keeping passive house cost competitive with whatever the cheapest thing that's legally possible to build is, I think, really critical to making sure it's actually successful. So that's something I'm very interested in, is how can we actually do passive house certification at essentially, as close to cost neutral as possible.
Ms. Abudaram?
Hi, I'm going to out myself. I work with Kingspan Insulation, so my question is about insulation. Is there a reason, I'm based in the New York Metro, so like full disclosure, we have very rigid codes centered around fire performance. And the easy push button solution in our market has been just throw a heck ton of mineral wool in the wall and call it a day. Bearing in mind that it's a semi-rigid board, it doesn't perform so well thermally or otherwise over time, that the embodied carbon is extremely high, and it's probably what's contributing. It's likely the polyiso and the mineral wool that are contributing to the embodied carbon on that one slide we were talking about. Is there a reason why it seems to also be the push-button solution in Boston or in the Northeast in general, that on these projects we're defaulting to mineral wool?
I can speak a little bit to it. I mean, I think NFPA 285 is a concern for teams, and they just know if we do mineral wool, that's a very straightforward solution to it. I think polyiso on roof insulation is kind of our default, and so I certainly think that's very common as well. I think both can work. We've done polyiso as well as mineral wool in certain schools. It just depends. There's pros and cons to both. So I think the flexibility of passive house is good, so teams can pick what's right for them.
Got time for a few more questions. Let's keep them quick because that clock's a little fast, but we're running low on time.
Could I just follow with you, Ryan, on that? And for all three of you guys, keeping the costs low, like what have you seen as the best value for dollar? And if you could wave a magic wand and introduce a new, get away from some of the rigidity of the pathways or whatever it is, if you could kind of solve the larger problems that you're trying to solve in meeting after meeting and model after model, like breaking the mold, what would it be? What would be your...
We've tried to get our teams to look into like a recycled glass aggregate for the below slab insulation, because I think that is one of the embodied carbon hotspots. And I haven't been able to convince teams to do it yet because it's just different from what we've done in the past. But I think that's one way to take a product that's essentially upcycled into something that performs two functions. It's aggregate and it's some insulation. So Glavel is one of the companies. But again, it's kind of, I think, with the public bidding environment, that is a big challenge because there need to be three different companies that can do it. I think there technically are, but one of them might be, yeah, go ahead.
So we do have that in our spec, and we were actually really close to getting it on Squantum because we wrote a performance spec so it could be equal to other options. But didn't happen in the end.
Okay, there's a questioner online. What's the name? Bill. Bill Shadid? Bill. Yeah.
You got it.
Bill
Yeah,
online. If you can hear me,
I
you can
can
go
hear
on
you.
unmute.
Yep, I can hear you. Can you hear
Speak
me?
to us, Bill.
Can you hear me? I've unmuted.
We can hear you.
Got it. Yeah, I just have a question for the panel. It's awesome to see passive house being used on schools as a newer building type within the passive house or passive building kind of movement or trend. I'm curious from each of your perspective, when you think of the core passive house pillars, whether that be, you know, what the five pillars, four to five pillars, what was the one that you found, one or two maybe, that the ones that you found hardest to achieve in this building type, being K through 12 schools?
I guess it's, yeah, the space conditioning criteria, like just achieving those. I guess also the source energy. I think the easiest maybe to achieve, although it might not seem that way, is comfort, because like all of the principles that we're working with are coming together. But yeah, I think just like making sure we get those space conditioning criteria to the FIA standards.
No, I mean, I think for us, and it's one of those calls where we had where I said, don't tell me about my building's not compact enough. I'm like, it's a school. And it has a courtyard, and we're preserving a historic portion of the existing building. And I'm like, we have to make this work within this setting in order to say that this works universally. And so that was a challenge for us. We ended up just automatically having fiberglass windows because we were just trying to meet the space conditioning criteria, so that then it helped us with the thermal comfort criteria on the windows. But you know, that's something that from the beginning I was like, if I'm going to sell this to my client, I need it to be something that's not just like, oh, this specialized thing that this one project could do. I'm like, this is a public school, it's publicly funded, and we need to prove that we can use this in a universal way, that any other building could do this, right? Because, I mean, that's what we've been doing with net zero schools for years. And so I really kind of pushed back on that, which I think was great because we got good response. And, like, you know, being able to work with a DCB protocol and all of that was a way to, you know, I felt like I was always there, like, representing, like, every project that's going to come next, right? We have to figure out how this can work universally.
Yeah, just working within each project's bounds, and like Kate was saying, the surface area was different for the walls, so like optimizing in different areas and how that all works together. Yeah.
Mr. Yule.
Well, Kate just brought up fiberglass windows, which sort of teased me up a little bit. So I have a question about embodied carbon, sort of two-part question, but we touched on the fact that there was a 60-year like sort of runway on the embodied carbon analysis. Also sort of acknowledged that schools often are maybe a little bit longer than that. In the glazing world, 60 years is interesting because it kind of falls in between the expected lifespan of a couple of different potential like solutions. When we do that embodied carbon analysis, are we counting things? And I realize on the mechanical side, like everything has different service life, right? But are we counting envelope components like more than once when necessary? Like, and how did that inform some of your analyses?
Yeah, so like on a 60-year life cycle, the windows would be replaced. We typically, you know, Squantum's a brick building. We're not replacing facade. You know, you're just replacing caulking, ceilings, doors, windows, that kinds of things, roof.
Okay, we're going to try and close out with do you have a quick one here?
Yeah, my question is, much of the Passive House Massachusetts audience has been focused on multifamily construction. So what is the number one thing that you would say is really different about building a school versus residential, like in terms of the Passive House requirements?
I think for us, it's like when we're doing a multifamily project, and we've had a handful of them, we know it's very easy to say, this is what you're going to do. Here's where you have flexibility. You're going to pick between kind of systems here. This is going to kind of be like that. I think schools are so unique that even though multifamily is very unique, some of them have courtyards, some of them don't. There's lots of difference in the massing of them, but I think schools have so many more variables that even after going through this and hearing Ryan talk, we've done this presentation 3 times now, which I feel bad we couldn't do Jess's part when we've heard him to say it 3 times. That I just think that, like, I'm not sure that we're there yet with, like, can we do I think we can do this on every school, but I think it's going to be harder to know all the, okay, I can go in and just like, I can design to this without doing a model for 3 months.
It was iterative.
But now that protocol exists and other people can use it. So I just think it's a little bit like, it really stresses the starting very early, like, you know, where other project types just, I think even if we've done 10 of these, we still won't be able to say like we know what's going to necessarily work.
Yeah, I would just say like I actually came from like a commercial building standpoint into the FIAS world, then working on multifamily and then working on these schools. So yeah, I just feel like the multifamily projects in comparison are a little more uniform there, and there's more calculations available to them in this FIAS or PHI world. There's just like the procedures are in place, the calculations are there. And yeah, for these projects, there were just certain things that were really, really unique that we needed to come up with new calculation, or you know, others on the team need to come up with new calculations to figure out how do we actually estimate these things. So yeah, just like the uniqueness. Yeah.
Okay, I'm going to use my privilege to ask the final question here because we run over time. The 7%, I'm still hung up on the 7% reduction. It just seems low because I'm imagining you're hitting, you know, 40% reduction in energy use on average, right?
So the 7% was comparing it to a net zero school. So we didn't compare it to ICC baseline, which you compared it to a non-mass amendment ICC baseline. I was comparing it to a net zero school. So I took 3 new construction net zero schools that we've done and said, okay, what was the common, you know, assemblies common, and then we also looked at the energy use compare. So these projects are already very efficient. So because I was interested in like, are we actually getting anything out of this from going from here to here? So that's what my analysis was. And so it's different. So we didn't see significant decreases in MEP because we were already making the efficient system. The systems were already really efficient. We weren't adjusting the loads enough. So that's what my assessment was looking at. So maybe that makes it a little.
That makes so much more sense. I just missed it the first time. That's helpful. Okay. Well, now that concern has been set to rest.
So this isn't like, you know, whatever, ICC 2015 they're comparing to or something, or even ICC 2021. This was like, I'm already a net zero building. I'm already at an EUI of 20. How much lower can I go, and what am I getting out of the embodied carbon I'm putting in?
Yes. Okay. Thank you. Thank you very much. All right. Let's have one last round of applause for our speakers. Thank you to everybody who joined us here in person and online.